So in this video, I'm going to show you an example of tracing through the binary search algorithm. So starting out, we're going to search for the number 7 in this list. And I have down here on the right the Python tutor code that we're going to kind of follow along with as we do this binary search. So looking at what the algorithm tells us to do, we first of all need to define a couple variables inside that algorithm. L is going to just be defined as 0. R is going to be defined as the length of my list minus 1. Well, the length of my list is 1, 2, 3, 4, 5, 6, 7. So 7 minus 1 is 6. So I started out with L equal to 0, R equal to 6, and then I want to define M to be the floor of L plus R divided by 2. So that is 0 plus 6 divided by 2. So that's going to be the floor of 3, but since 3 is an integer, that's just going to be 3. So L, starting out, L is 0, R is 6, and M is 3. So now we are down here in this while loop, and as long as L is less than or equal to R, we do this. All right, so L is 0, which is certainly less than 6, so we have to do what's inside the while loop, which we did. We started out by defining M to be the floor, and now we look at this if construction. So it's saying if M, which is 3, if A3 is less than T, which is the number we're searching for, then what do? Then we redefine L to be 3 plus 1. Well, let's check and see if that's the case. A3, here's A0, A1, A2, A3. So that's saying if it's saying if A3, which is 5, so if 5 is less than 7, which it is, then I'm going to redefine L to be equal to 4. So now I have L equals 4. So we're in the situation where R is 4 now. L is 4, R is still 6. So let's look back at the algorithm. So since we ran this, we did this if construction, we go back to the while loop and check it out again. While L is less than or equal to R, well, 4 is less than or equal to 6. So we're still continuing in the for loop, and now I have to redefine M. M is going to be the floor of 4 plus 6 over 2. That is the floor of 10 over 2, which is just going to give us 5. So now we have to continue in that while loop and check that if condition again. So now it says that if A5 is less than 7, the number we're searching for, then I'm going to redefine L to be 5 plus 1. Okay, but in this case, A5 is going to be, here's the 0, 1, 2, 3, 4, 5. Here's A5. So it says that if 8 is less than 7, then I'm going to redefine L this way. But this is not true, so I don't do any of that. So I go on to the next part of the while statement, which says else if this condition. So what's that saying? That says else if A5 is greater than 7, the number I'm searching for, then R is going to be defined as m minus 1, or in this case, 5 minus 1. Well, this condition checks out because 8 is greater than 7. So I'm going to redefine r to be 5 minus 1, which is 4. So now I have L equals 4 and R equals 4. All right, so we just ran this elif construction, which gave us a new value of R. So we have to go back and check the condition of our while statement again. So as long as L is less than or equal to R, well, 4 is less than or equal to 4. So we're still running the while construction. Here is how we're going to define M again. M is, as usual, the floor of 4 plus 4 over 2. That is the floor of 8 halves, which is going to give us the floor of 4, which is just 4. So now L is 4, R is 4, and M is 4. So let's look at these ifs and the elifs. So first we say if A4 is less than 7, the number we're searching for, then we do something by redefining L right here. However, A4 is 0, 1, 0, 1, 2, 3, 4. So A4 happens to be 7. But 7 is not less than 7, so we don't run this construction. Next, in the while loop, since this one didn't work, we look at the elif. And the elif says that else if A4 is bigger than 7, then we're going to do something. But A4 is, again, 7, and 7 is not greater than 7, so we don't run this construction. So we continue down in the loop for loop, and now we're at this else. Else return M. So that means we're going to return 4. M equals 4. And so what we've done is we've found the location of the number we're searching for, where this is the 0th location, the 1st, the 2nd, the 3rd, the 4th, the 5th, and the 6th. So this algorithm, remember, it returns a location in your list. So the location of the number we're looking for is 4. And so we've found the number we wanted with the binary search algorithm.